Hi there. So in this video, we're going to take a deep dive in looking at logarithmic functions. More specifically, what does it mean to take a logarithm and properties associated with logarithms. Up at the top, we've been working with exponential expressions, and I start you up here with, 3 squared. Of course, we know 3 squared is 9. And I say, well, you might be surprised up here to learn that another way to write 2 is actually log base 3 of 9. That's what I have right here. Oops, I need to get my pen, don't I? And I'm going to talk us through, how does that work down here below. So a logarithmic expression is of the form log base a of x. So that's the way it is read, log base a of x. So when we see log base 3 of 9 equals 2, it's read just as I just said, log base 3 of 9 equals 2. So, as I said, well, what does this logarithm mean? And what it technically means then is that 3 raised to what power equals 2? And equals 9, excuse me. Got ahead of myself. 3 raised to what power equals 9? And then we know, okay, well, x has to equal 2. That's the idea of any logarithm, that you're always looking to, your base raised to the opposite side equals your argument. And so here I'm saying 3 raised to the second power equals 9. So just down here below, I want us to practice, thinking through what does it mean to take this logarithm without using a calculator. So here in example 1, if I wanted to evaluate log base 3 of 9, then technically what I'm thinking to myself is 3 raised to what power equals 9, and we know, okay, well that has to be 2. The next one, log base 2 of 8, I'm thinking 2 raised to what power equals 8. And then we say, okay, 2 to the first is 2, 2 squared is 4, 2 cubed is 8. So there's our answer. Then the next one, we'll do one more here together. 3 raised to what power equals 27. That's what it means to take a logarithm, that the base raised to some power equals this argument here. So I'm asking myself here, 3 raised to what power equals 27? Hopefully you agree. That's also 3. I recommend pause the video, try example 4 and 5, make sure you're tracking with me. All right, just below that, you'll see a question. It says, well, what is the common log and what special notation do we see if we're working with a common logarithm? And, this is a preview of logarithmic functions, so you may have never seen a logarithmic function before. So if you haven't, the common log is a logarithm without a base. But if you don't have a base, that base is understood to be base 10. So like, for example, if you just see log of 12, for example, then that is understood of a base 10 sitting down there, okay? If it is considered to be base 10, then the base will not be written, and it would just be written as log 12. So example 6 and 7, you'll see like that. So let's do example 6 here together. So when I say let's find the log of 100, then we're utilizing the same technique that we did before in terms of how do we evaluate this. Remember, there's an imaginary base down here of 10. And so we're thinking in our head, 10 raised to what power equals 100? And hopefully agree that would be 10 to the second power, right? 10 squared is 100. All right, you pause the video, try example 7. Remember, if you have a logarithm without a base, it's assumed to be base 10. We'll move on down to the last question here on this front page. It says, well, what is a natural logarithm and what special notation do we see if we're working with a natural log? Natural log is a logarithm that's abbreviated as ln. Okay, you'll see that there, ln. And the base is understood here to be letter E, okay, and that base E is a naturally occurring constant. It's you'll see that in the in your notes in your 171 class, that E is, we actually derive it for you, 2.71828 and so on. It's not a huge deal at the moment, but what you need to take away is that there is a common log, and it is written as log, and it's considered to be base 10. And then there is natural log, and it is considered to be base E, okay? And that B is that E, excuse me, is a naturally occurring constant. All right, let's flip it on over. In example 8, it wants us to evaluate the natural log of E squared. So remember that this is an imaginary base E down here, so we're saying E raised to what power equals E squared. And if you think about it, you're trying to figure out e raised to what power is going to equal e squared. Well, the only way that these two expressions here are going to equal the same is if the exponents were the same, because the bases are already the same. So when the bases are already the same, you can just set the exponents equal to one another, and you have your answer. So here, x equals 2. Because if you think about it, if you replace that x there with 2, then e squared definitely equals e squared. The rule moving forward is when you have the same base, that you can drop those bases and just set the exponents equal to one another and solve. Because you're going to see as we move forward that there'll be cases where, like, maybe you have x squared plus 2x equals 2, and we'll have to solve that, for example. I'll let you try example 9. And then I'm going to move on down here to this fact down here below. It says, when the base of the logarithm and the base of the argument are the same, the answer will just be the exponent. So a couple of examples that I've given you here. I used a common log here on the left and the natural log over on the right. So for that first one, I have log of 100. So as I mentioned previously, that log, if the base is not written, then it's assumed to be base 10. And so this is what this fact is saying, is that when the base and the argument match up, then your answer is just the exponent. Because think about it, you're thinking, when you say log of 100, then you're thinking log base 10 of 100. You're thinking 10 to what power equals 100? Oh, it has to be 2. So when the base when the base and the argument match up, the answer is just the exponent. And I didn't mention this, but what I did with this argument here, 100, I rewrote it as the base 10 raised to a power. So that's always advantageous for you, is to have that the base and the argument be the same. So another way to write 100 is 10 squared, and that made the base and the argument be the same. Just the example over on the right, natural log of e cubed, this is base e. The base and the argument match up, so the answer is just the exponent, 3, final answer. So again, here it's saying e to the what equals e cubed? Well, x has to equal 3. So let's do a couple of these down here in example 10 below. You're evaluating each of the logarithms without using a calculator. Essentially, you should be able to use these properties that you're seeing up here. So for that first one, natural log of e to the 1/2. Remember, there's an imaginary base e down here. Base and argument are matching up, so answer is just that exponent, 1/2. All right, letter B, log of 10. Remember, this is log base 10 of 10 raised to the imaginary first power. Base and argument are matching up, so answer is just 1. Let's do another one, log base 5 of 25. Can I rewrite 25 as 5 to a power? And hopefully you agree. Yeah, you can do that. That 25 is the same as 5 squared. And by doing that, base and argument match up, so the answer there is just 2. Okay. Let's go down and let's do f together. Log base 2 of 1/2. So let's think about some ways that we can rewrite this. Log base 2, think about this 1/2 as written as, this is 1 over 2 to the first power. Wouldn't it be legal for me to rewrite this as log base 2 of 2 to the negative 1 power? Isn't that legal? So, I mean, if you have a negative exponent, we know that we can bring it to the bottom and make it positive. Well, if I brought it to the top, then the exponent would be negative, right? If you they work both ways. So now you have your base and your argument matching up, so your answer is just the exponent of negative 1. Okay, let's scoot on down then and let's look at letter I. In letter I have log base 2 of 1. So here, remember there's no way that I can write 1 as a power, as 2 raised to a power. So let's think about, okay, well, what does this logarithm mean? This logarithm really means 2 to what power equals 1. And we've talked about this in a previous video. Anything raised to what power is always 1. Anything raised to the 0 power is always 1. So here, log base 2 of 1 is just 0. Anything raised to the 0 power is always 1. All right, so I will let you then pause the video and go through the rest of those, either trying to make the base and the argument match up, or utilize what we know to be true about logarithms, that the base raised to some power equals the argument. Okay. All right, let's move on down then to the bottom of this page. And this equivalent exponential and logarithm expressions. If a to the x equals y, then log base a of y equals x. So essentially what we're going to look at on the next page is how do we go from exponential to logarithmic and vice versa, logarithmic to exponential. So I think I mean, you can see here that the base of the exponential becomes the base of the logarithm, and so that's a correlation there. And then the exponent is what you equal, and the what you equal is the argument. Okay, so that's the correlation. I think you'll see it better on the next page though when we actually put it to some problems. So here an example at the top of the next page, I have us looking at, I want us to change each of these exponential expressions into an equivalent logarithmic form. So if I have 2 to the x equals 726, then I want to rewrite this in logarithmic form, and this would be log base 2 of 726 equals x. And think about it now, if you wanted to undo this, base raised to the right-hand side equals the argument. 2 to the x equals 726. Sure enough, that's what we have. 3 to the x equals 81. So this would be log base, the base of the exponent here, or the base of the exponential function is the base of the logarithm. So this would be log base 3 of 81 equals x. And if you undo it, the base raised to the right-hand side equals the argument. 3 to the x equals 81. Okay, and let's come on down here and do letter F together. You'll notice in letter F you have e to the x equals 178. So anytime you have an e, then you want to use natural log. And so to go to logarithmic form here, this would be the natural log of 178 equals x. I mean, we know that natural log is base e. If you want to write that base e, you certainly can, that e to the x equals 178 as a check. I encourage you to pause the video, go back and do c, d, and e, take these exponential functions and convert them to logarithmic form. Then I'm going to scoot on down here to our last example. I want to convert these logarithmic forms into exponential form. So that is base raised to the right-hand side equals the argument. So here this would be 7 cubed equals x. Letter B, 1/3 base raised to the right-hand side equals argument. And then let's go down here and do letter F together. You don't have a base. It's natural log, so that base is understood to be e. So this one would be e to the 9th equals x. Okay. All right, let me know if you need anything. Thanks a lot. Bye.